Students, you are welcome to Lectures with Dr. Barnes. So let's take a look at this question. So far we have been treating Fourier series and we have looked at the trigonometric Fourier series with several examples. Today, let us look at this example in exponential Fourier series. So in exponential Fourier series, just as in trigonometric Fourier series, we first determine our period. So our period is from minus 4 pi to minus 2 pi, minus 2 pi to 0, 0 to 2 pi, 2 pi to 4 pi. At all these instances, the signal repeats itself, so they are our period. So let me just take 0 to 2 pi. Okay, I like to take including 0 so that it makes my preceding procedures much more easier to deal with. So my period here is 2 pi. So in that case, omega naught is equals to 2 pi on t, which is equals to 2 pi on 2 pi, which is equals to 1. Okay. And then my general Fourier series equation using the exponential form is x of t is equals to co plus summation up to infinity, n is equals to negative infinity. You have to remember that in the trigonometric Fourier series, n was always equals to 1. Okay, into cm into e j n omega naught t. Okay, so this is the equation. Okay, this one please is omega. All right, so now from here, okay, our CO is equals to 1 over t into t naught plus t into f, no, not into, let me say, into x, okay, into x of t, okay, dt. So here I'm going to have 1 over 2 pi into what? 0 to 2 pi. 0 to what? 2 pi into x of t. So into x of what? T dt. But I don't know my x of t. You see, in this case, what I must do is that I must find the equation of this slanted line, the line which makes an angle with a 0, okay, with all the slanted lines, this slanted line, this slanted line, this slanted line. But I can just take one and then it represents all of them, okay. But for the straight lines, the perpendicular lines, that one is okay. You don't have to find any equation for them, okay. So now, finding the equation for these lines, I'll have to I have to take a point. So here I can take 0, 0. Here I can take what? 2 pi a, okay. There I can take 2 pi a. So now what I have to do is that I must write these points, okay, and then find the slope for these points, and then equally find the equation for these points, okay. So now let me just write the points. So now say points. I'm having 0, 0, and I'm going to have 2 pi, a. Okay, so I'm going to have these points. Okay, so now my slope m is going to be a minus 0 over 2 pi minus 0, which is going to be a on pi. No, a on 2 pi. Okay, now my equation is going to be f. No, I keep writing f of t. No, it's x of t, because I'm too much acquainted with the trigonometric Fourier series. Because we're just coming from there. We just finished that one. So x of t minus the y component of the first point, 0, okay, equals to the slope. So a over 2 pi into what? T minus the y component of the first point, which is 0. Okay, into 0. Okay, so basically this one will give me a over what? 2 pi into what? T. That will be the equation, and that is acceptable because you can see that my line is what? From 0, 0 to 2 pi a. That is, the line is ascending, so the slope has to be positive. And then because it's passing through the x-axis at 0, the intercept will be what? 0. So the intercept here is 0. So my line equation can be trusted. Okay, and this is for the interval 0 and then t and then 2 pi. Okay, so it's for this particular interval. All right. So now from here I can just go on and find my C naught. So I'll just put into the equation. My C naught is going to be 2 pi into 0 into 2 pi into a over 2 pi t into dt. So this is equals to a over 4 pi, a over 4 pi into 0 into 2 pi into t dt. Okay, so here C0, C0 is actually going to be equals to a over 4 pi into here I'm going to have t squared, okay, t squared over 2, okay, 0 to what? 2 pi, which is equals to which is going to be equals to, let me see. So what it's going to give me is that it's going to go to this place. So I'm going to have a over 8, okay, place here is supposed to be pi squared, okay. I'm going to have 8 over, I'm going to have 8 into pi squared into here. I can have this squared, okay, it's going to give me what? 4, it's going to give me 4 pi squared, okay, 4 pi squared, okay, 4 pi squared, and then minus what? Minus 0, okay, minus 0. So here C0 is going to give me, this will cancel this, okay, this will cancel this, okay, it's going to give me a on 2. So this is going to be my C0, okay. So my C0 is going to be what? A over 2, okay, my C0 is going to be a over 2. So now, having been able to find my C0, I have to go on ahead and then find my Cm, okay. So I'll go ahead and then find the Cm also. Okay, so now with respect to my Cm, this is what I'm going to do it. Okay, so Cm. Okay, so Cm is equals to 1 over T same, okay, as the other one. Okay, here T0, here T0 plus what? T into what? Into x of t, into x of t, into what? Into e minus j n omega naught t dt. Okay, so this is actually equals to 1 over 2 pi into 0 and then 2 pi into x of t. So x of t here is a over 2 pi t, okay, into e minus j, okay, e minus j, but here omega naught is what? 1. Omega naught is 1, so it will be n what? Nt, okay, it will be nt. Alright, so this is going to be my Cm. So now here Cm is equals to a over 4 pi squared, okay, into 0 and then 2 pi into what? T e what? Minus j n t. Okay, here is what? The t. Alright, so here also the t, which is equals to, here I can use integration by part. Okay, I can use integration by part. So if I use integration by part, I'll have a over 4 pi what? Squared into what? I'll take t and then I will integrate e exponent minus j n t. Okay, so then I'll have what? T, and then I'll have e minus j n what? T over what? Minus j n. Okay, minus j n. And then I'll come here to the other part. Please, we did integration by part in the trigonometric Fourier series. Okay, if you don't know, you please revise that one, or you go over your maths curriculum, your maths syllabus. You're going to see integration by parts somewhere in your maths university engineering mathematics. Please study that one too. Okay, so here you integrate this t. If you integrate this t, you get 1. And then you differentiate this e exponent minus jnt, you integrate it 2 times. Okay, in that case, I'm going to get, so if I actually do this one, I'm going to get minus. Okay, I'm going to get minus. But what I also have to remember there will be that yes, I'm going to get minus. Okay, let me write a minus. So if you integrate this, if you integrate t, you get 1. And you integrate this one, first time you get e exponent minus jnt over minus jnt. Then integrate again, you get e exponent minus jnt over minus jn squared. Okay, so from the integration by part, I'll get e exponent minus jnt over here. Then I'll get minus jn, okay, all what? Squared. Okay, so this is what I'm going to have when I use the integration by part. Okay, when I use the integration by part. So now I can close this bracket here, and then I can introduce my my limits like this. Okay, so now what I can do again is that I can put in my limits. Okay, I can put in my limit and then move on. Okay, so putting in my limit, and what I'm going to have is I'll have my a over 4 pi squared out, and then here always put in the upper limit first, so 2 pi first. Okay, so what I can have is I can have 2 pi. Okay, and then I can have this minus jn. Okay, I can have this minus jn. Okay, so let's say 2 pi over minus jn. Okay, when you have e exponent minus jnt, what happens is that you get 1. Okay, you get 1. Okay, and then you come here. So here too is going to be the same thing. You get 1 over minus jn. Okay, squared. Okay, so here you get minus 1 over minus jn squared. Then now you put in 0. If you put 0 here, the whole thing becomes 0. Okay, if you put 0 here, you get what? 1. And then 1 over this one. But the 0 is because it's a lower limit, it has a negative. And there's also another negative here, so it will become plus. Okay, so it will become plus 1 over minus jn squared minus jn all squared. Okay, now you can close your bracket. Okay, so now this is what we get. But now what you can see is that these terms are the same. They are equal, so they can cancel each other. If they cancel each other, then my cm is going to be left with a 4 pi squared. Okay, a 4 pi squared into 2 pi over minus j what? N. Okay, so this one can cancel this one. Okay, okay, they can cancel that one. So if it cancels that one, then what I'm going to get is I'm going to have cm is equals to a over 2 pi n. Okay, and then minus what? J. But from complex numbers, okay, this one can be equals to a j. When this j comes up, it becomes positive. Okay, in complex numbers, so into 2 pi what? N. Okay, so now my cm is equals to what? aj over 2 pi what? N. Right, so that's it. So now my Fourier series, okay, putting it into the original Fourier x of t. Okay, it's always x of t in the exponential method. That's why we use to differentiate it from the trigonometric Fourier series method. Okay, so here c naught plus what? Plus summation up to infinity, n is equals to minus what? Infinity cm into what? Jn omega naught what? T. Okay, so now here x of t is equals to a naught, which is what? A over 2. Okay, plus here summation up to what? Infinity. N is equals to what? 1. N is equals to minus infinity. Okay, so here I'm going to have what? A what? J over what? 2 pi n. Okay, AJ over 2 pi n. Okay, into E J n omega naught what? T. So what I can say is that x of t is equals to A over what? 2 plus A and then 2 pi can come out. Okay, so A over what? 2 pi can come out, and then I can have my summation like this. And it's equals to minus what? Infinity. Okay, I can have J over n. Okay, into E J n omega naught what? T. Okay, so now, very important with the exponential Fourier series is to plot your frequency spectrum. So the frequency spectrum is nothing but a plot of the amplitude with the frequency. Okay, it's a plot of the amplitude with the frequency. So briefly, let us see how we can be able to realize the frequency spectrum for this question that we have. Normally, what happens is that we plot the frequency spectrum for our CM component, okay, for our CM aspect, all right, okay. But I have to tell you that here, okay, here it is for n equals to you see that this place, so I've already found n not here. Okay, so this place, n equals to, I've already found n0 here. So this place, you see that this is the, I've already found C0, this C0. So this one is what? C0. So this one corresponds to what? 0. So here, the n cannot be equals to what? 0. Because I've already found C0 here. So okay, so it's for n not equals to what? 0. Okay, and it is for the interval 0 less than what? T less than what? 2 pi. Okay, so let's go back to our frequency spectrum. Okay, our frequency spectrum. All right. So for our frequency spectrum, how we plot it is that we will use the CM component. Okay, so for the CM component of it, what we're going to do there is that we're going to have our CM was actually equals to AJ over 2 pi n. All right. So now we're going to assume for the values. Okay, we're going to assume for the values. So now let's say that C1. If we have C1, then we're going to have what? AJ. We're going to have what? AJ over what? 2 pi. All right. So that's C1. What about C minus 1? Okay, if we have C minus 1, then it's going to be what? AJ. Okay, it's going to be minus AJ over what? 2 pi. Okay. What about if we have mod C1? Okay, so mod C1 will be what? A over what? 2 pi. Okay, A over 2 pi. And mod what? C1 minus. Okay, mod C1 minus will also be what? It's going to be the same thing that we're going to what? Have. Okay, it's going to be A over what? 2 pi. So if we have what? C2 is going to be what? AJ. Okay, over what? 4 pi. Okay, AJ over 4 pi. And then C2 minus is going to be what? C2 minus is going to be minus AJ over what? 4 pi. So mod C2. So C2, mod C2 is going to be what? AJ, no, sorry. So C2 is going to be what? C2 is going to be C2 mod C2 is going to be A over what? 4 pi. Okay, and then mod C2 minus is going to be what? A over what? 4 pi. Okay, so this is how it's going to be. Alright, so now if we should go on to C3, C3 is going to be what? AJ over what? 6 pi. And then C3 what? Minus is going to be what? AJ over what? 6 pi, but there will be minus here. Okay, and mod what? C3 is going to be what? A over what? 6 pi. Okay, A over 6 pi. And then mod C3 minus is going to be what? A over what? 6 pi. Okay, so that's how we do it. So now we're going to do the plotting. Okay, so now for the plotting, this is what we're going to have. So we're going to have the frequency aspect, but here remember our frequency is what? Omega naught. Okay, our frequency here is omega naught. Okay, omega naught. And then here, this is our amplitude aspect. So it's a plot of the frequency with the what? Amplitude. So here is what? Cm. Okay, so now here, the first aspect, what did I get? I got what? So I did what? C1. I did what? C2. I did what? C3. Okay, C3. Okay, and then but please, you can just write. We write here. You can just write here 3. You write here what? 2. Okay, and then you write here what? 1. All right, and then here minus 1. Okay, but C minus 1, and then here minus 2, but C minus 2, and here minus 3, but C minus 3. Okay, so here is what? 0. So for 0, there was nothing at 0, so I have to leave that one blank, and then go to 1. 1, I had, if you check 1, this is what I got. I got what? A what? 2j. A what? 2j. Okay, so I'll just write A over 2j. Okay, A over what? Sorry, A over 2 pi. Okay, and then here I got what? A over what? 4 pi. Okay, see that A over 2 pi is longer than A over 4 pi. Okay, so A over what? 4 pi. And here it's more shorter because it's A over 6 pi is shorter than A over what? 4 pi over 6 pi. So the same thing will come here. Okay, so the same thing will come here. It's what? A over what? 2 pi. And here A over what? 4 pi. Sorry, A over what? 4 pi. Okay, and then here A over what? 6 pi. A over what? 6 pi. Okay, so this is how you plot what? Your frequency spectrum. This is the end of this question. Thank you, class. See you in the next class. Thank you so much.